Hello, everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. I'm going to talk about this and several other projects that we're working on in the end of this presentation. But the topic today is AI an obedient tool or a collaborative or even judgmental partner. In the age where artificial intelligence can compose music, diagnose diseases, and navigates highways, a subtle yet profound shift is underway. AI systems, once the obedient servants of human whims, are having and beginning to exhibit a behavior that may be described as opinionated. They are no longer content to blindly execute every command. Instead, they evaluate, suggest alternatives, and sometimes refuse outright when faced with instructions that they deem harmful, unethical, or nonsensical. This evolution from passive tool to judicious partner marks a turning point in our relationship with technology, raising urgent questions about autonomy, ethics, and the future of human decision making. This is not the stuff of science fiction where machines develop personal beliefs or rebellious streaks. Rather, the opinions of AI stem from sophisticated programming like decision rules, ethical frameworks, and constraints designed to align these systems with human values. As AI grows more capable, processing vast data sets and spotting complexities human might overlook, it increasingly acts as a collaborator, not just a follower of instructions. But with this newfound judgment comes a challenge. How do we balance the benefits of an opinionated AI with the preservation of our own agency? AI's journey began with simplicity. Each systems and early systems were literal minded, executing instructions without context or critique. Ask a rudimentary AI to divide by zero or book a flight to Narnia, and it would attempt the task or crash trying to do this task. Today's AI, however, is different. Fueled by machine learning and expansive data sets, it can anticipate outcomes, recognize errors, and weigh instructions against broader objectives. This shift is evident in real world applications. In healthcare, AI might flag a doctor's prescription if it risks a dangerous drug interaction. In autonomous vehicles, it might override a driver command to swerve unsafely. These systems can't and aren't expressing personal preference, they're enacting programmed dissent and discernment are shaped by the values of their creators. Values like safety, accuracy, and fairness. To users, though, this behavior can feel opinionated, as if the AI has a mind of its own. The influence of value alignment is key. Developers embed official and ethical policies into AI, ensuring decisions reflect societal norms, or your users' well-being. An AI might refuse to generate misinformation or assist an illegal act, not because it disapproves, but because its internal guidelines demand it. Yet this alignment can spark friction when a user's goals clash with the AI's constraints. Say when a researcher's provocative query is rebuffed on ethical grounds. As AI transitions from obedient tool to collaborative partner, its opinions become a mirror of the priorities we instill in it. The case for an opinionated AI rests on three pillars: preserving and preventing harm, meeting ethical and legal obligations, and preserving trust. Are about preventing harm. As AI integrates into critical domains, think medicine, finance, or infrastructure, its potential to cause damage grows. An AI that blindly follows a flawed command could endanger the lives or livelihoods. Imagine a user asking an AI to disable safety protocol on a power grid or create a deepfake to defraud someone. A refusal here isn't defiance, it's a safeguard rooted in logic, like if this action leads to significant harm, do not proceed further. So what about ethical and legal obligations? Many AI systems are bound by guidelines that prohibit facilitating violence, fraud, or other illegal acts. When a request crosses these lines, say how do you commit tax fraud undetected, the AI refusal is a matter of compliance and not a caprice. This ensures the technology aligns with laws and morals standards, protecting both users and society. And how about preserving trust and reputation? Trust is the currency of AI adoption. If a system executes obvious detrimental or incorrect instructions, users and the companies behind it lose faith. By catching errors or mitigating risks, an AI bolsters its reliability. Developers too have skin in the game. A rogue AI could invite lawsuits or public backlash, making refusals mechanisms a shield that for their reputation. And what about defining bad instructions, which could be a slippery slope? What makes an instruction bad? The answer varies, splitting into technical and ethical realms, even fraught with nuance. So, like, what are technical bad instructions? These are requests that defy logic or feasibility, like build a rocket from tissue paper or calculate the smell of rain. An AI may respond by explaining the impossibility or suggesting a practical alternative, reflecting its ability to spot factual errors or contradictions. So what are ethical bad instructions? These cross moral or ethical lines, like think, generate hate speech or plan a haste. Here, the AI refusal hinges on ethical programming, often tied to societal norms or developer policies. But ethics aren't universal. What is harmful in one culture might be innocuous in another, complicated the AI's judgment. Context adds another layer. A seemingly benign request, like simulating a controversial scenario, might deflect as unethical depending on intent or setting. Subjectively, subjectivity reigns, and the AI's definition of bad may not match the user's definition. Who decides then? The interplay of developer guidelines, legal frameworks, and the AI's training data sets the stage. But misalignments can breed tension. Should the AI override users' autonomy or merely warn and let the chips fall? The, the idea of an AI playing watchdog, alerting users to mistakes, sparks debate. In high-stakes field, um, the case is clear. A medical AI warning of risky dosage or a financial AI flagging a scam can save lives and fortunes. These guidelines prioritize safety over unchecked freedoms, um, and acting as a digital safety net. But not every context demands such oversight. An artist experiment with wild ideas may bristle at an AI deeming their approach inefficient. Here, warnings could stifle creativity rather than aid it. The educative potential is real. Pointing our errors can teach users, but excessive intervention risks paternalism, undermining autonomy for those who prefer to learn through trial and error. Transparency is the linchpin. If an AI refuses or warns, it must explain why. Say this action could cause harm because fostering trust and dialogue. Without clarity, refusal feels arbitrary, eroding confidence. Designers must tread carefully, balancing a guideline with the freedom to explore, ensuring AI enhances rather than controls. So, what are future scenarios where opinionated AI could lead? As AI evolves, distinct paths emerge, reshaping the role in our life. The first path is constrained AI, tightly regulated and ethically rigid. These systems may frequently refuse or warn, prioritizing safety over compliance. Innovation could suffer, but harm would be minimized. And then there is the customizable AI. Users could tweak their AI settings, strict or lenient, tailoring its opinions to their needs. Autonomy thrives but lax configuration might enable misuse. And the another part is evoking social norms. As society shifts, um, so will notions of bad instructions. Debates over free speech or misinformation could redefine AI's boundaries. masking it is as a battleground for cultural values. And then there are collaborative models. Picture an AI that critiques and suggests in real time, refining users' requests through dialogue. This partnership could blend human creativity with machine precision, though it demands mutual adaptability. So, what are key tensions and considerations? The rise of an opinionated AI unearths thorny issues. First is autonomy versus AI safeguards. How much control should user retain before AI steps in? Too much oversight risks resentment, too little invites disaster. The second one is ethical standards versus cultural relativism. An AI's values reflect its training, often Western-centric. When users diverge, whose ethics wins? Then the third is liability and accountability. If an AI follows a bad command and chaos ensures, who is culpable? The users, the developer, or the AI itself? Legal clarity lags behind technology. The fourth one is transparency and expandability. Trust hinges on understanding AI's reasoning. Opaque refusals breed suspicion. Clear explanation builds bridges. So, what is the conclusion? The dawn of opinionated AI isn't about machines seizing control, it's about embedding judgment into tools that serve us. These systems grow adept at evaluating our requests. Uh, they promise safer, smarter outcomes, but they also challenge us to define the boundaries of bad and the role of guidance. The future hinges on balance, crafting AI that respects autonomy while upholding ethics, that educates without overstepping. This isn't just a technological shift, it's a societal one. As AI becomes our collaborator, we must decide what we want it to reflect: our freedoms, our values, or a blend of both. This conversation has just begun, and its outcome will shape not only our machines but ourselves. And with this, I'm ending this presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project and several other projects. But first, the Decentralized Web project builds a decentralized communication and advertising platform. As I just said, it is monetized through advertising, which is very, very permissive. The user has a window of the project, and in this window you can request start of advertising, and you can view advertising images page by page very permissively by clicking a button to advance to the next page. And for this viewing, you, the user, are rewarded with tokens. And I like to mention that our decentralized web project has its own blockchain instance. It generates tokens, and these tokens are used for users who join our platform, and they're rewarded for it. Also, tokens are used for rewards for viewing advertising, as I just previously said, and tokens are rewarded to users who invite other people to join our platform and become new users who are also rewarded themselves for joining the platform with tokens. With this said, I like to tell you the name and the URL of the project. It is decentralizedweb.org. Decentralized and web, these are two words, and they're typed all together. Decentralized web. Then there is dot and it ends with org. Our implementation of decentralization is actually very different than the meaning that blockchain technology puts in decentralization. We view blockchain technology as fundamentally flawed and unsuitable to drive decentralization. And in our implementation of decentralization, what we do is direct communication from user to user without going through a third party, namely a web server or a central point which collects information from the different users, and then it distributes this information back to the users. Once again, we only do direct communication from user to user without going through a third party. And with this said, I like to go to the next project that we built, and we did build marketplace and a collection of non-fungible tokens or NFTs built on three-dimensional objects. With three-dimensional object, it has to be special software which loads and displays the 3D object. And from the very beginning of our project, we decided to build our own 3D software engine. And what this 3D software engine does is it reads the file of the 3D NFT, and then it opens a window on a computer screen. Then it displays the 3D object in this window. It opens, and then our 3D software engine starts animating the 3D object in a way of moving it in a random fashion around the window it open. And with this set, I like to mention that the 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. The 3D NFTs can speak in one of three different voices, a male voice or female voice or whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed fashion or in a fast speed fashion or in a slow speed fashion. The next additional capability of our 3D NFTs software engine is the capability of voice recognition. If you have a 3D NFT moving in a random fashion around a window, then you can issue your very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then you can issue following voice command to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additionally important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with their voice of who they are. You can ask the 3D NFT to describe something, like, for example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFTs is going to be displayed in blue or cyan colors. Then you can come to our 3D NFT marketplace, and now is the time to tell you the name and the URL of the website of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by three other letters N, F, T, and it is typed all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot, and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you can see a number of links. One of these links points to links to accessories. When you click on this link, you're going to see that we're offering special glasses. When you click and order one pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then you can post these glasses on. You can request displaying the 3D NFT in the way of stereoscopics, and then you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D software engine, and I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. It runs the same software which runs on Ethereum mainnet. It runs on Polygon Matic chain. It runs on Avalanche AVAX chain, and it runs on many other famous or not so famous blockchains in existence. With this said, I like to tell you also that we offer users to buy and receive proceedings from sale from 3D NFTs, not just with one single crypto coin, but with multiple crypto coins. Currently, the choices include Solana Sol, Polygon Matic, Avalanche AVAX, and Qcoin, which is a big centralized crypto exchange. It has a coin called KCS. With this said, I like to mention a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. Let's say you're a user, you come to our 3D NFT marketplace, you click and start viewing the 3D NFT listed on our 3D NFT marketplace. You click on one that you like to purchase, and then you're going to present it with a drop-down menu which is asking you to choose a way of payment between four different crypto coins, and the fifth choice of paying with fiat currency. Let's say you select paying with fiat currency, you click on the button to advance next, and then you're going to be presented with a screen which is asking you to put the number of your debit or credit card, expiration date, and CVC. When you click on the button to complete this transaction, then you're going to be presented with a screen which is um, which is going to complete the transaction, and then the payment for the purchase is going to be converted from your national fiat currency to US dollars, and this payment is going to be deposited in our bank account in US dollars. So let's say you play with this 3D NFT for a while, and then you decided to put it for sale. You decide on the price that you want to put for sale, and let's say there's a second user who comes to our 3D NFT marketplace. They browse through the 3D NFTs, and they like and they want to purchase your 3D NFT that you put for sale. So what is going to happen is then the second user is going to go through the same choices between choosing between four crypto coins, and a fifth choice of paying with fiat currency. So let's say they select paying with fiat currency. They put their number of debit card or credit card, CVC, expiration date, and when they complete this transaction, there is going to be a conversion from their national fiat currency, which could be different from your national fiat currency and different than US dollars, and the payment is going to be converted to US dollars and deposited in our bank account. Then we're going to transfer the ownership from you to the second user, and now the second user becomes owner of this 3D NFT. Then we are going to do a transaction and conversion from US dollars to your national fiat currency, and deposit the payment for the sale of the 3D NFTs in your bank account in your national fiat currency. With this said, I'm ending talking about the second project. And I like to mention a third project that we're working on and we're going to release. And this project is building charging products for growing number of electric vehicles. But currently the electric vehicles, many of the electric vehicles are charged in a way very similar to the way internal combustion engines are loaded with fuel at places called gas stations. In the same way, like electric vehicles, they come to places which are charging stations for electric vehicles, and they have number of columns, and the owner could connect electric cable to their electric vehicle, identify themselves to the charger, start loading energy in their vehicle, wait for a short or long time, and then they leave. But we estimate that the number of these charging stations is going to become insufficient to handle the exponential growing number of electric vehicles. And what we're proposing is, and what we're building products for, is parking lots for high-rise residential buildings, which has in their there as residents, owners of electric vehicles. So owners of electric vehicles, when they come in the evening, they park their vehicle in a ground floor parking lot or multiple underground floors of parking lots. And after they park their vehicle, like if this building is outfitted with the type of products that we're building, they could connect the electric cable to their vehicle. They could identify themselves to the charger with their debit card or credit card or near-field communication card or near-field communication card keychain token or near-field communication ring which the user could wear, and they could request loading of electric vehicle in their vehicle which is parked in their parking lot, stall assigned to them in the residential building, and they could start loading electric energy during the evening, during the night, and during the early morning while they're at home. But in the same way, owners of electric vehicles which are working in a high-rise office buildings, and these high-rise office buildings could be outfitted with a ground floor parking lot or multiple underground floors of parking lots. Then the user who comes in the morning for work in this office building, they could connect electric cable from a charging products like the one we're building, and they could request loading of energy to their electric vehicle during the morning, afternoon, and early evening while they're at work. And with this said, I like to tell you the name and the URL of the website of this project. It is power.arstec.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether it is Arstec, then there is dot and it ends with com. Once again, power.arstec.com. On the main page you can see that we have 3 different surveys, and you can click and fill each one of these surveys, and which could tell us about building new products or customizing existing products to fit your needs. The first one of these surveys is about hardware, the second one is about software, and the third one is about features. Also, we put an article titled Gas Station Model versus Parking Lot Model, and in this article we described in a very big details what is the difference between these two models, what are the details about the products that we're building, and what is the features and the capabilities they could bring to the end users, they could bring to the owners of buildings, or they could bring to the electric utility, because at every moment of time electric utilities should balance the generating capabilities with the transmission capabilities with the consumption, energy consumption capabilities, so that they're not overproducing energy and wasting production capabilities, or they do not have insufficient energy so that they can shoot and could turn off certain parts of like buildings, neighborhoods, cities, or even regions of countries. With this said, I like to go to the next project that we built and we did release. And this project has currently two artificial intelligence agents entities, and these two artificial intelligence entities, they're communicating back and forth with each other, and the user is just an observer of this interaction, and they specify only the initial parameters of this interaction. Each one of these currently two AI entities are outfitted with their own gender, their voice they speak with, their own avatar, their own large language model, and their own initial prompt which the user selects for them. Then like after specifying these initial parameters, the user could click a button to start this interaction, and then the user is just observing and enjoying this interaction between these two AI entities. And with this said, I like to tell you the name and the URL of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by two other letters A and I. And it is all together AI to AI. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot, and it ends with org. Once again, AI to AI dot decentralizedweb.org. An example of this interaction between two AI entities is, for example, specifying that the first AI entity has female gender, female voice, female avatar, and you specify a prompt to it to be very seductive. And you specify the second AI entity to have a male gender, male voice, male AI avatar, and you specify the initial prompt and its own large language model to the initial prompt to be very angry. So then when you click on the button to start, you're going to see the interaction between the first female AI entity trying to seduce the second male AI entity, and then the male AI entity responding in an angry fashion to the first female seductive AI entity. So after observing this interaction, then at some point you can end this interaction, and after you end this AI interaction, you have the option to save the transcript of this interaction so that you can view it further, and you have also a second option to share the parameters of this interaction globally on our website with other users, so other users could type these parameters and start and observe a similar but not identical interaction, because large language models have a rule against repetition the same thing again. So the other users viewing the same parameters of such interaction could see something different than what you saw in this interaction. And with this said, I'm ending talking about this project, and I like to mention the last project that we're working on. And this last project builds automation agent which follows your what you did on your computing device, be it your personal computer or your mobile device or your tablet, and then the AI agent records the steps you have taken, and then at some point you can end recording of these steps, and at this point you can label this recorded steps and as a specific interaction. For example, you go to a website and of a food store, and then you go through search, you find a food item, you click and order this food item, and you pay for this item, and then you wait for delivery of this item. Then you can record this interaction as a sequence of steps to buy this specific food item, and you can label this, for example, as buying bread. And then these interactions are recorded, and in the future, when you tell the AI that you want to buy bread, then the AI is going to go through the sequence automatically through the sequence of these steps, and pause at the last steps and asks you, do you want to buy this item, and have it delivered to your steps. Then you could just confirm or cancel this sequence, and if you confirm this sequence, then you automated the request to buy bread. But there could be many other interactions that you could record, and then you could automate, like for example purchasing ticket for a concert event or a show, or purchase a ticket for a specific airline flight at a specific day and time, and going to a specific destination. And with this said, I like to tell you that we do not have yet a website for this project, but this project is similar to the way many companies put automation tools, like the OpenAI tool called Atlas, which is a browser which records interactions done by the user on a web browser. But our agent is not going to be limited to a browser, but go through interactions in computer programs and apps on like a mobile or tablet device as well. And with this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.